Welcome all. In this video, we are going to see operations on matrices. Okay. Now we are having four basic operations, that is addition, subtraction, multiplication and division. We are familiar with all these operations. Okay. Now matrices is arrangement of numbers. Okay. And on this arrangement of numbers or this matrices, we can perform certain operations, that is addition, subtraction and multiplication. But there is some certain conditions which the matrices should have to follow or should have to obey, and if that conditions are satisfied, then only we can add or subtract the matrices. Okay, and we can multiply the matrices. Now when the addition is possible, now first operation is addition. Okay, this is a very basic operation. When we go in the market or anywhere from early morning, we have to add something. Okay, so that addition is similar. Means what? We can add two numbers. As we can add two numbers, 2 plus 3 is 5. Okay, so when the addition of matrices is possible, we are going to see in detail in this video. Then we are going to see multiplication of a matrix by a scalar and the negative of a matrix, and then we will go for the subtraction of matrices. Now when the two matrices can be added, so for additions, if they have same orders, okay, so only one condition is there, that we can add the two matrices having the same order only. Okay, suppose A is a matrix, okay, and its elements are given by Aij, whose order is m by n, and B is another matrix whose elements are given by Bij and whose order is again m by n. This m and this m, n and n both are equal. Okay. So these two matrices have the same order. Then we can add these two matrices and the resultant matrix will be A plus B. So A plus B is what? It will be Aij plus Bij. It is a matrix obtained by adding the corresponding elements of the matrices, and its order will be the same as that of A and B. The resultant matrix will have the same order as that of A and B. So if A is a matrix whose order is m by n, B is a matrix whose order is m by n, then we can add these two matrices and the resultant matrix will be having the order m by n. So how to add it? Suppose I will take an example. For example, if A is a matrix, it is a matrix of order 2 by 2. Suppose this is a matrix of order 2 by 2, and B is another matrix and whose order is again 2 by 2. And it's a matrix of order 2 by 2. So we can add these two matrices. So A plus B. So what we have to do? We can add these two matrices as their orders are equal, and while adding the matrices, what we have to do? We have to add their corresponding elements. Means A11 will be added to B11, A12 will be added to B12, A21 will be added to B21, and A22 will be added to B22. So the corresponding elements we are going to add, that is 2 plus 1, 3 minus 3, 1 plus 4 and minus 1 minus 5. So what is it? As usual, as we use the rules of addition, the same rules we have to apply here. So 2 plus 1 is 3, 3 minus 3 is 0, 1 plus 4 is 5, minus 1 minus 5 is minus 6. So the resultant matrix will be having an order 2 by 2. Okay, so this is the matrix addition. While doing the matrix addition, we have to be careful that the two matrices which we want to add, they should have same order. Okay, and we have to add their corresponding elements. That's it. will see multiplication of a matrix by a scalar. Suppose A, Aij, M by N is a matrix, given matrix, and K is any scalar. Any scalar? Scalar means any real number, okay? Any scalar quantity, okay? And K is not equal to 0. K is not equal to 0. And if we multiply this matrix by this scalar, that is Ka, then it will be equal to, it is a matrix like this, M by N. Means we have to add the every element of this matrix by K. Okay. For example, suppose A is a matrix 2, 3, minus 1, 4, 5, 1. Okay. This is a matrix, and we have to find 5A. We have to find 5A. So what we have to do? We have to means 5 into A. A is matrix 2, 3, minus 1, 4, 5, 1. Okay. Now while doing this scalar multiplication, what we have to do? We have to multiply each and every element of this matrix by 5. So that is 5 into 2, it will be 5 into 2, 5 into 3, 5 into minus 1, 5 into 4, 5 into 5, 5 into 1. So each and every element of this matrix will be multiplied by 5. So it is equal to 5 to the 10, 15, minus 5, 20, 5 5 the 25, 5 1 the 5. So this is again a 2 by 3 matrix. It is a 2 by 3 matrix. Okay. So if any matrix is multiplied by a scalar quantity, then you have to multiply each and every element of that matrix by that scalar, which we are going to multiply. Okay. So this is the multiplication of a matrix by a scalar. Now using this concept, now in general, what you can say, if suppose Aij is a general matrix, okay, then Aij will be equal to K times Aij, and you have to multiply each and every element of this matrix by K. Okay, so that is multiplication of a matrix by a scalar. Now this concept, multiplication of a matrix by a scalar, we will use it for the negative of a matrix. For the negative of a matrix. Negative of a matrix means what? Now suppose A is a matrix, given matrix, and instead of any scalar, if I consider K is equal to minus 1. If I consider K is equal to minus 1, then we have to use the same concept, that is the multiplication of a matrix by a scalar for finding the negative of a matrix where this K is minus 1. So instead of this minus 1 into A, that is equal to Ka, and that is equal to K times Aij, this matrix, that is equal to what? Minus Aij M by N. Means if we take the negative of every matrix, every element of a matrix, then we get the negative of the matrix. For example, A is this, and we want to find the negative of A, that is minus A. Negative of A is denoted by minus A. So minus A will be equal to minus 1 into this. So you have to multiply each and every element of this matrix by minus 1. We have to multiply each and every element of this matrix A by minus 1. So it is minus 2, minus 3, minus negative of minus 1 is plus 1, 4 its negative is minus 4, 5 its negative is minus 5, 1 its negative is minus 1. So this is the negative of a matrix. Means in general, if A is a matrix, then minus A is negative of that matrix. So A minus A is negative of matrix A. minus A is negative of matrix A. So addition, we have seen here addition of two matrices, when we can add the two matrices when their orders are equal, and while adding we have to add the corresponding elements. Simple addition is a very simple operation in matrices. Then multiplication of a matrix by a scalar. If we want to multiply a complete matrix by a scalar k, then you have to multiply each and every element of a matrix by k. Okay, and negative of a matrix is what? Negative of a matrix, if A is a matrix, given matrix, then negative of a matrix is denoted by minus A. Minus A means minus 1 into A. So using this concept, multiplication of a matrix by a scalar, we can find the negative of A, and I had given here the example. So negative of A minus A is given by multiplying. We obtained negative of A by multiplying each and every element of the given matrix by minus 1. So using this concept of negative of a matrix, we can now do the subtraction of matrices. We can now do the subtraction of matrices. So fourth operation we are going to see, that is subtraction. Now addition and subtraction are the similar processes. Okay, so the similar conditions are applicable for the subtraction also, that while finding the we can subtract two matrices if and only if they have the same orders. Okay, for example, if suppose A is a matrix, suppose 2, 3, minus 1, 5, 4, minus 6. This is a matrix A, and B is another matrix. You can say 1, 0, 1, minus 2, 3, 4, minus 1. Suppose this is a matrix, another matrix. Okay, B matrix. Now what is the order of this? There are 2 rows and 3 columns. So this order of this matrix is 2 by 3. Order of this matrix, 2 rows and 3 columns. So it is also 2 by 3. So these two matrices have the same orders and we can subtract them. Okay. So how to subtract? So A minus B means, as usual, we have to subtract B from A. So that is A minus B. So A minus B, 2, 3, minus 1, 5, 4, minus 6, minus 0, 1, minus 2, 3, 4, minus 1. Okay, so this is the negative of matrix B. So you have to do, what we have to do? We have to take the negative of each and every element of B. So you can convert this in addition and take this minus sign with the each and every element of B. So this 0, it doesn't have any sign. You can means plus or minus, you can apply any one. Minus 1, minus into minus is plus 2, 3 minus, that is minus 3, minus 1 into 4 is minus 4, minus 1 into minus is plus 1. Okay, and now do the addition as we had done, that is 2 plus 0, 3 minus 1, minus 1 plus 2, 5 plus, this is minus 4, 4 minus 4, minus 6 plus 1. So what is it? It is 2 plus 0 is 2, 3 minus 1 is 2, minus 1 plus 2 is plus 1, 5 minus 3 is plus 2, 4 minus 4 is 0, and minus 6 plus 1 is minus 5. So this is the answer. Okay, so while doing the subtraction, what we have to be careful about, that when we have to subtract two matrices, their order should be same, and when we are going to subtract, we have to subtract the corresponding elements. Thus, in general, if A is matrix given by Aij having order m by n, and B is a matrix given by Bij having order m by n, means the orders of both the matrices are equal, then we can add them that is A plus B, that is equal to a matrix formed by adding the corresponding elements of these two matrices, that is Aij plus Bij, and the resultant will have the same order, that is n by n, and A minus B, that is subtraction of these two matrices, will be the matrix obtained by subtracting the corresponding elements of these two matrices, that is Aij minus Bij, and having the same order, that is n by n. And the scalar multiplication of a matrix is given by Ka, that is K multiplying each and every element of this matrix by K, that is a matrix formed by Kaij having same order n by n, and the negative of a matrix A is denoted by minus A, and it is given by taking the negative of each and every element of a given matrix A, that is minus Aij, and having the same order n by n. Thank you.